Hello everyone, we'll continue our lessons on Higher Mathematics 2, and this is the first lecture, Functions of Several Variables. Real-valued functions. Real-valued functions of several independent real variables are defined analogously to functions in the single variable case. Points in the domain are ordered pairs, triples, quadruples, and tuples of real numbers, and values in the range are real numbers as we have worked with all along. Do you remember the single variable function? Yeah, it was like this: y equals to f of x. It was single variable function. Single variable function. Why? Because there is just one single variable we have. It is x. It was x. Now we want to learn multivariable functions. Suppose D is a set of n tuples of real numbers, such as x1, x2, etc. xn. A real valued function f on D is a rule that assigns a unique single element real number w to each element in D. The set D is the function's domain. The set of w values taken on by f is the function's range. The symbol w is the dependent variable of f, and f is said to be a function of the n independent variables x1 to xn. We also call the xj's functions input variables and call w the function's output variable. Yeah, before we said we took just the real number x from the set D, and we took another number w or another number y from a set D, and we assign it for each single x, single y, and we said that single variable function. But now multivariable function variables are starts from x1, x2, etc. xn. Here's an arrow diagram for the function z of equals to f of xy. What is f of xy? F of xy is a double variable function. It has two variables, x and y. F is a function that assigns a rule, and z is dependent variable. X and y are independent variables, but the z is dependent variable. As you may see here, we can choose x and y whatever we want. This is x-axis and this one is y-axis. I can choose it from here. I can choose from there. What is this? This is the domain D. Domain D. I can choose it from everywhere where I want. If I say this is x1 and y1. Sorry. And it will be somewhere here. Somewhere here. There will be f x1 y1. So we have to take not just the number, we have to take a pair of numbers xy, ab, x1, y1, and this function f assigns a rule for this pair to find a number from a set D, which we call z. In defining function of more than one variable, we follow the usual practice of excluding inputs that lead to complex numbers or division by zero. If f of xy equals to 2y minus x squared, so f of xy equals to 2y minus x squared. In this case, it says y cannot be less than x squared. F of xy equals to f of xy equals to 1 and it's greater than xy. Xy cannot be 0. The domain of a function is assumed to be the largest set for which the defining rules generates real numbers, unless the domain is otherwise specified explicitly. The range consists of the set of output values for the dependent variable. These are the functions of two variables. For example, the first function, which is that equals to square root of y minus x squared. What is its domain? How to find its domain? We know that the expression under the square root cannot be negative. Cannot be negative. It can be 0. It can be positive. So how to find its domain? In order to find the domain of this one, I have to think that this expression is greater than or equal to 0. So I will write here y minus x squared greater than or equal to 0. How to solve this? Let's solve for y. Let us add for both parts x squared. I will get y greater than or equal to x squared. This is the domain. This is the domain. We have found the domain. And what about range? What kind of number I can get if I put any number from its domain here? Let me think. Can it be negative? No, because we cannot put negative number inside or under the root, under the square root, and it means we cannot get negative number as an answer. How about 0? Yeah, when y equals to the x squared, it will be 0. Yeah, it can be 0, but all the positive starts from 0 to infinity. 0 is included. There is another example, 1 over xy. So 1 over xy. This one is in the denominator, so denominator cannot be 0. So 1 cannot be divided by 0. We will say xy cannot be equal to 0. So it's the domain. And how about its range? Can this expression be 0? The expression. No, the expression can't be 0 also. So its range starts from negative infinity till 0 and union 0 to infinity. This is the range. The third one, z equals to sine of xy. Its domain, entire plane, because we can plug in any number, any degree to the sine function. It's defined everywhere. So the domain is entire plane. Entire plane, it says plane. Plane is this one. X, y, xy plane. So we can choose xy pairs from here, from here, from here. Everywhere we wish. And range. We know the range of this sine function. It starts from -1 to 1. Both are included. These are functions of 3 variables. Okay. The first function, w equals to square root of x squared plus y squared plus z squared. What is it? So here we have a gain square root. So this expression must be greater than 0 or equal to x squared plus y squared plus z squared, greater than or equal to 0. Let me think. X squared, is this number greater than 0? Yes, of course. How about this one? Yeah, this one also. So all these numbers are greater than 0 or equal to 0. Maybe x can be equal to 0, y. So this expression are always true. So domain is entire space, not the plane, space, because we have to choose 3 numbers. 3 numbers. It's function of 3 variables. Function of 3 variables. We know how to draw this space, right? We drew it like this. X, Y, this is O. we can choose from anywhere in the space. And its range, because we have here a square root, so we always get positive number, maybe sometimes 0. So range starts from 0 to infinity. Another one, w equals to 1 over x squared plus y squared plus z squared. Again, we have this kind of expression as previous one. So this part, denominator cannot be 0. X squared plus y squared plus z squared. This kind of expression now, it cannot be 0. These numbers are always positive, except sometimes they can be 0. So in order to this function define it, we have to find its domain. In which domain it's defined? So if this is equals to 0, the x, y and z should not be, or x, y and z should not be, or maybe x and y equals to 0, that should not be. So we can say these three numbers cannot be equal to 0 at the same time. Any of them, it's okay. Two of them, also okay. But three of them cannot be equal to 0. So this is its domain. And range. Here we have all the positive numbers, sometimes 0. So if we divide 1 by some positive number, we'll get again positive number. And if we divide 1 to any number, we'll never get 0. So the range starts from 0 to infinity, but 0 is not included. The next one, xy times ln z. ln is natural logarithm. What kind of numbers I can put instead of x? Any number. How about y? Also any number. How about z? Here z should be, you can choose any xy, but z should be greater than 0. So we have to take a number from this part of this space, not from that part. We also have that part. We also can take from this part. We can choose any x, any y, but only positive z. And its range, because we can choose any x and any y, so we can get negative number, positive number, sometimes 0. Range starts from negative infinity till positive infinity. A point x0, y0 in the region R in the xy plane is an interior point of R if it's the center of a disk of positive radius that lies entirely in R. A point x0, y0 is a boundary point of R. If every disk centered at x0, y0 contains points that lie outside of R as well as points that lie in R, the boundary point itself need not belong to R. The interior points of a region as a set make up the interior of the region. The region's boundary points make up its boundary. A region is open if it consists entirely of interior points. A region is closed if it contains all its boundary points. So what is going on here? What we are talking about? So in this case, you already know how to find the domain of a function, and you are familiar with the domain and also with intervals. If you remember, we got this kind of interval while we're solving some exercises. Like we said here maybe 0 and here like 3 and other numbers. And when we solved some exercises and we did this kind of expressions in order to find, so we can say it's from 0 till 3. So we can say it's from 0 till 3. 0 till 3. This kind of. We call it that interval. But interval is just for single variable function. For the functions that contains two variables, we can't call interval. We call region or disk region, and we have boundary points. Here we have just 0 and 3, but in that case we may have this kind of domain. So this region is a domain, so it may have boundary point here, there, and other places. So for the single variable we call interval. For the multivariable, for two variables, we call it region. Region can be Open if it consists entirely of interior points. These are boundary points, but as we know here, 3 is boundary point for this interval, but it's not included. In that case also, if all of these boundary points, the region has these boundary points, but it consists entirely of interior points, all the points here, all the points, not this boundary point, we call this open. But if contains all its boundary points also, not just 1 or 2 boundary points, all boundary points, we call it closed. And here another example was graph interior and boundary points of a plane region. So this is in an interior point, and that one is a boundary point. If you see interior point, it's already also situated, located in interior. But in this case, it's half part, the radius half part, outside of this plane region. So this one called boundary, this is called interior. Interior points and boundary points of the unit disk in the plane. Unit disk. We know we used this unit disk many times when we started to learn trigonometry, when we explained sine function, cosine. We also used this one, unit disk. So, open unit disk. In this case, it's open unit disk. Every point an interior point. We don't have boundary point included. Boundary of unit disk. It's just boundary. We don't have interior points. And the third unit disk contains all boundary points and interior points. A region in the plane is bounded if it lies inside a disk of finite radius. A region is unbounded if it's not bounded. Are you clear with this? A region in the plane is bounded if it lies inside a disk of finite radius. A region is unbounded if it is not bounded. Next definition. The set of points in the plane where a function f of xy has a constant value, f of xy equals to c, is called a level curve of f. The set of all points x, y, f of xy in space for xy pair in the domain of f is called the graph of f. The graph of f is also called the surface. Z. The set of points x, y, z in space where a function of 3 independent variables has a constant value, f of x, y, and z, is called a level surface of f. A point x0, y0, z0 in a region R in space is an interior point of R if it is the center of a solid ball that lies entirely in R. A point x0, y0, z0 is a boundary point of R if every solid ball centered at x0, y0, z0 contains points that lie outside of R, as well as points that lie inside R. The interior of R is the set of interior points of R. The boundary of R is the set of boundary points of R. A region is open if it consists entirely of interior points. A region is closed, contains its entire boundary